Hi, everyone. Welcome to the .NET user group for November. As everyone knows, tonight, the past 4 years is kind of the most important day of the year. Kevin's giving a talk. Obviously, that's the only thing that's happening right now. So we're going to be talking about what's new in C#. Next month, we're going to be doing another Microsoft AI cohort. AI season user group. I'm going to be hosting that one and speaking. So that's going to be the first Tuesday of next month, so December. So be watching out for that meetup group link. Without further ado, Kevin.
Waiting. Okay, I'm going to wait till I actually get the blue light before I start talking. Welcome, everyone. Thank you for coming. As Dan said, .NET user group. We will be talking through stuff that is new in C#. First, I'm going to address a couple elephants in the room. One, the logo for this talk may have been slightly misleading because the logo said, what's new in C# 9? Now, since C# 9 came out 4 years ago, we're not going to cover that. Instead, it's C# 13 .NET 9. So the versioning in .NET land is weird. We have the language version, which we are now at 13. Every November, we get a new one, so the number just keeps incrementing. And then .NET versions get weird with historical stuff. We had .NET Core, .NET Framework, all of this stuff. At .NET 5, they decided we're going to do sane numbering, and we're just going to increment every year. So we've now done that 4 times. We're now up to 9, which is why the version number mismatch. There is a link for those people online or people on Meetup that will get shared out to the repo that I'm going to go through. Everything that's in here is sitting inside of branches. And so this branch that we're currently on is called tooling stuff because I'm really good at naming things. So, if you are wanting to follow along at home, pay attention to the branch indicator. I'll call them out as we bounce through things. And that is where we're go. The full list of stuff is at that link. There is a lot of stuff there. Microsoft puts together very exhaustive lists of every possible thing from SDK to runtime, and a lot of features that most human beings don't care about. There's like 4 people that care about some of the cool features that they did. So we're going to hit the highlights and then work our way back from there. So we'll start here. One of the first things that you run into when you grab your latest version of .NET is there is a bunch of code analyzers. So people who run with warnings as errors turned on, all of a sudden your code that used to compile just fine and perfectly clean now has extra stuff being flagged. This is not bad. This is Microsoft adding in extra checks for things that you probably shouldn't have been doing anyway. It's just that now they're telling you about them. So a few kind of key ones that should be obvious. One, don't pass non-nullable things into argument null exception. This analyzer should hopefully be obvious. Ints can't be null, so we don't check them for null because that's kind of dumb. In addition, when you do this, it actually causes the int to get boxed. So in addition to being a poor check, you take a performance hit on top of it. So they added an analyzer to tell you not to do that. This one here, this one is probably going to flag on people that have older code or things that you've copied off of Stack Overflow from the olden days. Is substring, you always give it a start position and a length. And if you have gone through and used that overload, there are now newer ones where you just need to pass the first parameter, right? So in this case, if all we want to grab is world, we only need substring 6. We don't need message.length -6, all of that jazz in there. Not anything technically wrong with the code, but you open yourself up to fun bugs where when you change one of your numbers, something's off, you walk off the end of your array, bad things happen. Don't do that. Avoid inexact reads with stream read. Now, most people don't end up going directly to streams for a lot of stuff. We'll feed them into a stream reader or something similar because it's a friendlier API. If you do end up reading from a stream directly, though, you should be checking the return value. This is one of those APIs that I'm used to looking at in code reviews because I know it's problematic for people. But when you do a read, you're not guaranteed to have it fill the whole buffer. If you ask for an array of length 10 and your stream only has 5 things in it, you get back 5 things. And so oftentimes it ends up biting people who aren't checking the return value because they fed it an array of length 10 and they expected to get 10 things back, but you only got 5, then the problems usually occur. And sometimes not obvious problems because your arrays get filled with zeros or were probably initialized to zeros, and that's all you got. So solutions, use your return value, read exactly. And then this one is the one that I was most disappointed to see because this one I will argue is flat out wrong. So if you are compiling a project that has an output type of exe, meaning you're building some sort of application, not a library, this only flags on exe compiled projects. But the suggestion is make your public types internal. Because typically when you're compiling an executable, the intent is for it to be an application, not a library. You don't anticipate something else referencing you like a library and using your types. You certainly can do that in .NET, and there are times to do it. And one of the most common is unit testing. If you go through on your application project and follow this one and make all of your public types internal, you've now shot yourself in the foot for unit testing. Because now you have to ask the question, how do I get access to those internal types? Do I expose my internals to my unit test project, which is one option. We have internals visible to as a feature where we can then port those out. Or do I work around this? Quite often, I usually tell people, leave the API surface public. It's by far easier. Otherwise, you do internals visible too. You gain very little by making it internal. You've blocked people from referencing you as a library. That's great. Is that really a big concern? So worth considering. That one's there. I disagree with the analyzer and probably will just turn it off. OK, let's take a look at some other ones. We'll burn through the easy ones. .NET Global Tools now offer you an option to roll forward. This is really just an advantage for people who are using things like .NET NAD Framework, where you install the global tool to create migrations. It allows you to use the tool on a newer framework version without the tool author needing to go and recompile. So it says, hey, I know this tool was compiled against, in this case, we'll say .NET 8, but I want to use it on .NET 9. Great. I can just say .NET tool install roll forward. Let me use it on .NET 9, and then you can pull that tool forward and keep running. Because the vast majority of the time, unless that tool is referencing some sort of API that's now dead, which rarely happens, it's probably going to work just fine on a newer version rather than an older one. Right? And this is specifically to pull forward for a major version, not a minor. We already roll forward for minors because those should work just fine. OK, MS Build stuff. This one for people who, there's a typo there, // don't do that. For people who actually care to look at like the MS Build binary logger stuff, this is really handy to be able to say, hey, check in case my output has double writes or similar. So this gives you a way of checking your build system. So if people are doing custom stuff in their CS prods, directory build props, et cetera, and you want to make sure that things haven't broken, this is a new fancy feature. Huzzah. OK, the one that most people actually care about, terminal logger. This has existed since .NET 8. Most people probably just don't know that it's there. So if you are on .NET 8, you can use this today. If you slap on the --TL onto your .NET commands, you will get the new terminal logger experience. If you've installed the new .NET 9 SDK, it is now on by default. So rather than getting the old long verbose thing, you get something that feels a little bit more modern on the output. Rather than just a bunch of standard out, just dump the screen, you get something where you get the little spinners and the progress. Very similar for people who are used to things like Docker or similar, where you do a Docker pull and you get the nice progress as all of your images and layers pull down. Great. This is now built into MS Build and .NET. You can obviously go and turn it off if you want the old behavior back. Questions, comments, concerns? OK, now we'll actually get to C# related stuff. Other big elephant in the room. So for people who have seen any of like the Microsoft Build conference talks about what's coming in C# and all the cool things, there was an awesome feature touted called extension everything. We've had extension methods in C# for several versions now. That's great. This was going to bring that same functionality to more things like properties. That feature has been pulled for this release. So unfortunately, if that was the killer feature you were hoping for, they have yanked the killer feature. I usually tell people that the .NET team has deep-seated commitment issues, they have no problem pulling features right up until the last second. And they can and will. So if they aren't confident that it's going to go out without causing problems, they will yank it. So unfortunately, we are now in the they have yanked a feature that some of us were really excited for, and hopefully we'll see revisited again. OK, so inside of C#, and this here is still C# v old, right? Let's imagine that we've got a couple tests here where we're just going to join some strings together, right? We've got a test that says hello world. We're going to join the strings hello and world. And we've got this little join method down here that takes a params array. So a params array allows us to be able to specify individual elements. The compiler automatically bundles that up into an array, calls it with the array for us. Everyone's happy. It lets us have kind of that var args for people who are familiar with like C or similar, right? The amazing new feature, drum roll please, because I'm sure everybody is going to be blown out of their socks for this. You no longer have to use an array. Congratulations. There's some of these C# features that can be very underwhelming. You can now use IEnumerable, IList, IReadOnly list, or similar. This prevents you from actually needing to go through and actually call toArray on the middle step. So before, on the two strings, when we got the strings back out, we had to call toArray in order to be able to pass them in. Now we can just pass it in directly. The one thing to be aware of is it does cause some very interesting problems when we start talking about overload resolution because of spans. So spans allow us to effectively take a view into an array or a list and act on just a section of it, sort of like a view into a database table. But they allow us to do it without causing extra allocations. So there's nice performance increases that come along with leveraging it. If your params end up being like a read-only span, this now ends up being something close to very close to zero allocations. So now you've gained a bunch of performance without needing to allocate that intermediate array. Normally the params thing, because the compiler would instantiate an array for you, that's an allocation. And in C#, we don't have performance problems. We have memory problems, memory problems, and memory problems. Because consistently, when problems occur, it's because the garbage collector ran. And the garbage collector runs when you allocate memory and then are done with it, because it has to go and clean up the mess. Right? So if we can avoid allocations, the garbage collector doesn't run, and we go faster. So in general, the way we make C# go faster is we try to cut our allocations down, and that will make yourself run a lot quicker. If you've got thread.sleep calls in there, I can't help you. That's a different problem. OK? Next one. And by the way, Dan is watching the chat online for people who are there. If you've got questions, feel free to drop them in the chat. He's informed me that he will interrupt me either with a hand wave or throwing something heavy. Whatever comes to his mind first. OK. You can see, switching branches very fast. OK, so here we've got a very simple little bit of code that is just doing locking. So this is leveraging benchmark.net just for performance testing, because benchmark.net can get us kind of low-level performance metrics of, did this code avoid allocations, did it run faster, et cetera, especially for things that are tiny and hard to measure with just like wall clock time. So in this case, we have a lock keyword to just guarantee synchronous access so that we can increment a variable. Because ++ is not thread safe because it's a read, an increment, and a write. We have to do something to synchronize access to this. And in here, we have what is a very common pattern for a conventional lock. Now, most people are familiar with the idea that the lock keyword takes a reference type in, not a value type. You don't want to pass something like an int. This is bad because it won't work. And in fact, it'll fail at you because you have to end up casting and learning how to spell. It's hard to type when people are watching because it ends up boxing the integer. You get a new reference every time, and your lock ends up functionally locking on a different instance, and then it's not actually locking if it's a different instance every time. So what we have now is a brand new type, a system threading.lock. And this new lock is more efficient than just locking on an arbitrary object. It allows it to use newer threading stuff with the .NET frameworks for things like the semaphores that are built in so that it can lock and unlock slightly quicker. On my machine, when I ran the benchmarks, the difference was like 14 milliseconds versus 16 milliseconds for these simple tests. I'll save you the trouble of running them because they take like 40 seconds to run or something. So is it faster? Yes. Is it significantly faster? Not really. But for people who are looking for high performance code, which is a lot of what is in the latest version of C#, is higher performance code. So if you are going to go through and do a lock statement, avoid locking on an arbitrary object. System.Threading.Lock is a much better alternative. The other thing that it brings you is slightly better APIs to play with. So rather than going through and always needing to use the lock keyword, the threading lock class also supports things like using statements. Because it supports things like using statements, it means it is idisposable. That means if you need to wrap it up in some sort of like try finally block or pass it around to have something else lock and unlock it, you now have an instance that you can do that with. Before, it was kind of obnoxious because the only alternative was with the monitor class, and you had to make sure that you passed the right object reference all the way around to call enter and exit in the right places. And because it was just an object, you could accidentally pass the wrong reference into anywhere else. This now helps avoid those types of problems. I think it's a little rare. Most of the time when you're taking out a lock, the recommendation is to keep the scope as tight as possible. You don't want to be arbitrarily locking for a long period of time. The other thing that this does not enable, you still cannot use this to lock around an asynchronous call. Okay? So even though it's like, oh, it's inside of a using statement, I know, I'll just make this async so that I can await because it supports using. No, the compiler will see that and it yells at you and says, nah. No, you can't do that. We still have the issue. Locking is inherently on a per thread basis, and asynchronous code means multiple threads. So it doesn't make sense. If you still need an asynchronous lock, Semaphore Slim is the answer there. Okay? Once, going twice. Okay. Here we go. And again, these are going to be very exciting. Okay. Has anybody ever even written a console write line like this? Anyone? Going once, going twice. Does anyone know what the funky looking characters are? Ben's sitting over there smiling. He should know the answer if he doesn't already. So usually the people who know this are people who do a lot of console apps or people who are roughly over the age of 35, 40. These are ANSI terminal codes, and shockingly still in use today for any sort of fancy terminal formatting. That terminal logger that we saw earlier, guess what it uses to do its fancy updating of the terminal? ANSI codes. Because we have the new fancy Windows terminal that supports all of the new terminal codes, we now have a terminal that behaves like terminals on other systems from a decade ago. Huzzah. The problem is that \U001B becomes a very common bytecode. That's the escape sequence. So the escape character actually has an escape code. And the problem is people had to remember either that in hex or binary or pick your favorite way of representing it. But now, in C#13, we have a fancy new literal we can use. It's just E. For those people online, there is roaring applause in the room. I'm sure you can't hear it. Thank you, Austin, the pity clap. I'll take it. Yeah, again, horribly exciting. We have an escape sequence. Will it be very useful to people? Not in particular, unless you're doing console output with ANSI codes, and then it's actually fairly useful. OK, why do you keep? Visual Studio has insisted that it wants to open solution files. OK, let's dive in again. OK, so back on C#, oh boy, I think it started somewhere around C#10. We started to get introduced to the idea of source generators. And before, partial classes were not overly useful to people. So partial classes allow you to take a class declaration and spread it across multiple files. In general, this is only done if you're writing code by hand. for some sort of organizational purpose, right? You've got something that kind of has to be big. And it's like, well, I'd like to group things together. I don't want my one file to get big, so I'm going to split this up across multiple files. Great, right? That's what we had since C# 1.0. It was fine. It just didn't get used a lot. Source generators came around, and then it immediately became a very valuable feature, because source generators run as part of the compiler, and they will generate out additional code for you. And so because they can't edit your existing files, source generators will often generate partial classes to be able to augment your code with extra stuff that comes along with this. And before, what we had is we had these partial functions. So we can see test1, and we can see over here we've actually implemented the other half of test1, right? And if we do terminal, new terminal, right? .NET test, because we can run tests. Hey, look, terminal logger. Isn't it pretty? It's colored and everything. We can see that the test passed. Clearly, Kevin is awesome. We can confirm that because it says so. There is a chance that my code might be slightly broken. We can never eliminate the test just being bad. That's always a possibility. So in C# 13, we can now do more partials than just functions. We can partial. So we didn't get extension everything, but we got partial all the things. So that's kind of cool. So we now can partial out our properties as well as indexers. Right? So rather than having to do something funky like we did before, now we can do public partial. Kevin is awesome. And over here, we can now go through and reference it. The thing to note about properties in particular is oftentimes we prefer to write properties as autoprops because they're easy, right? We do get semicolon, set semicolon, and we're done. When you are implementing a partial for a property, you can't do an autoprop. And the reason is because this looks remarkably like an autoprop. Aside from the word partial there's not really any other indication that this isn't an auto property. And so if you were to implement it with an auto property, the code would be identical. And the compiler would have no way of telling the difference between them. So if you do have a partial property, you do have to actually implement the property. Which is why over here, it's not just get semicolon. It's get true, because obviously that's the only possible value for it. Right? Questions, comments? I know. Very exciting. OK, keep going, keep going. More stuff.
Kevin?
Yo.
So in .NET 8, for .NET test, would you just append the terminal, the TL, to get that terminal command?
Yeah, so the question is in .NET 8, how do you go through and get that terminal command? So yeah, it'd be .NET test terminal logger. And there's also longer form ones of it, and there's an environment variable that you can set as well if you want to configure it more globally so you don't have to type it every time. Great. OK. Indexer. OK, so let's imagine that you are subjected to me making up a history test. Right? So we've got this historical events class. The historical events class has dates, right? And for fun, you can go look up the fancy thing that happened on all these dates. If we go down here, there's nothing fancy about it. Historical events, the dates are just straight date time array, and there's 10 items in here. So this isn't new. This is ye old stuff. We can go through and we can populate our array with direct indexes. And this is fine. But it can be mildly annoying if you wanted to hypothetically reverse this, right? Rather than going in chronological order, maybe we want the most recent at the beginning, reverse chronological, right? Obviously, the most important date is what we are doing now. We're going to ignore any major events that otherwise might be happening on today's date. We're going to just say that the user group is that one, right? If we take a look at what we now have, we can now index backwards from the other side of the array. So for people who aren't familiar with this syntax, this is something that came about with the new range and slicing functionality from, I think, first introduced C# 11, improved in C# 12, and now we can use it on initializers in C# 13. It just effectively says go backwards For people from other languages, they were used to having this functionality for a while. We get it too. Yay. I know. Very exciting. OK. I'll keep going. OK. OK. So let's imagine we have this horribly complicated program that adds two numbers together to equal the only possible random number I could think of. OK? So we have a adder class. The adder class takes in two ints, adds them together, and then returns the result. Right? And let's imagine that this adder class lives in a library that I'm maintaining and that I've gone through and done. Now, I assume that people using my code, they probably have something very similar to what already exists in program CS, where they are just invoking and they are probably passing through two literals. Right? And just looking at this, we can't actually tell what the signature of the add method is from this. We assume it's ints, because those are two ints. But it could actually be doubles, because the compiler is hip to the idea of, well, when you say 40, if the parameter is a double, I know what you mean. That'll be a double as a 40. And it works just fine. But as a library author, let's imagine I go through and I actually implement this guy with a double. I now have this interesting problem. If I want people to actually land on the appropriate overload, if I kill off the old one, I might break binary compatibility with my assembly. Because people who are previously compiled against my DLL expect the method signature to be ints. So if all I do is delete the int one and put in a double one, I've broken binary compatibility, and people are forced to recompile in order for it to work. If they recompile, that'll be fine, and it'll work, but now we've got a problem. So I want to leave both there. But now, how do I tell people, well, wait a minute, I really want you to use my double overload? Because the double overload is the better one for precision, accuracy. We're going to ignore the fact that doubles aren't precise. For whatever reason, I want to force people into that. So what I have now is this overload resolution priority. So normally what would happen when C# goes to figure out which overload to invoke, it goes through and looks for whatever's the best match. And there's a whole bunch of stuff in the language spec for what best match means. But it's going to look for the thing that's the closest to what you passed in. But sometimes you're like, well, I know there's technically a better match on the ints. But for whatever reason, I really, really, really want you to land on the doubles. So if we actually land here, and we do .NET run, we can see that it actually added through the doubles, which is cool. Now, if we go through and whack that guy and then run it again, we see that without that attribute, it does fall back to the original one. Because the best match, when the compiler is looking at adder.add and seeing a 40 and a 2, it goes, well, I've got the choice of double and I've got the choice of int. It looks like what you actually typed in here was ints. So I'm going to assume that that's the best match, and I'm going to go from there. I'm not going to bother to do an implicit cast from int to double for you, because that requires me to do extra steps. And I assume you wanted the thing with the fewest number of steps. But as a library author, I now have the ability to say, no, 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 this is actually the better one. This other guy is going to be obsolete in the future, but I don't want to break binary compatibility. Because if people are willing to recompile every time, that's fine. And most of the time, we don't worry a lot about binary compatibility. Right? Most of the time, we're bringing in NuGet packages. And when there's an update, we pull those in. But sometimes libraries aren't necessarily distributed via NuGet. Sometimes they're in the global assembly cache. Sometimes the DLLs are brought in and sideloaded. And in those cases, binary compatibility matters a great deal. You can swap out the assembly as long as binary compatibility matches. The moment it doesn't, your program crashes and everyone's sad. So this gives you now an option for hijacking the overload resolution. And I can think of about 3 different ways of how I'm going to abuse this in ways it was never intended to be used. Thank you, Microsoft. I appreciate those features. How many levels of priority can you have? As many as you want. This is an arbitrary int. So just so that you can control where things end up landing, the default is 0. So if you wanted to go through and flip it, you can make it up as you go. So they kind of left it arbitrary so that library authors could kind of figure out where they wanted to go. I assume in some cases people, if they're leveraging this feature a lot, they will probably do logical increments where they jump by like 10 or similar to leave themselves space for something else in the middle. Probably, for what it's worth. Yes?
I noticed you can set the same attribute twice with the same priority. Does it then just default back to default resolution at that point?
Yeah, so you can set the same attribute twice with the same priority. So if you end up doing the duplicate here, the integer value here just effectively ends up being an order by when it's looking at which one it's going to land on. I don't actually know what it's going to do when I do this, so falls back to the integer one because the priorities are equal. Because without it, it ends up treating them all as zeros, and this just allows you to get something bigger than 0 so that you can shove something in earlier. Great question. I hadn't even considered trying that one yet. Any more questions? Cool.
So larger number takes priority over smaller numbers?
Yes, larger number priority over smaller numbers. I suppose in that case I should check. I wonder what happens with negative numbers. Can you make something less likely to be resolved? Again, I have thoughts of how to abuse this in ways that it was clearly never intended to be used. Okay. Now we're going to start getting into areas that people use a little bit more. We can bust through the C# stuff. So this is where we get into this blurry line of what's new in C# and .NET. This is, we are now leaving the realm of what's new in C# and moving to what's new in .NET. Because C#, as you can see, the language features, there's nothing really major in there that's going to make me go and start writing my code drastically differently than I do today. Right? The language itself didn't necessarily gain a lot because we lost some of the coolest language features that hopefully come back in the future. But .NET, the underlying libraries, did get quite a few updates. Now, LINQ is something that most of us are probably familiar with quite a bit. We often use it on all of our collections. So here we have a set of people. And for whatever reason, the AI really liked J names. I had to force it to use something not a J because it really just, it got going on Jack, Jane, Joe, and I think it just figured, well, I see J, so I'm going to keep going. And it then promptly filled in all of the people. Person isn't fancy. It has a name and an age. But in these two tests that we have here, what we are looking to do is actually count and group the number of people by some criteria. In this case, I picked first letter of the name just as an arbitrary thing, but you can imagine people who have wanted to be able to say group by an attribute or a member of their type preemptively. And similarly down here, right? So the group by has kind of been our workaround for this. And the disadvantage of what is happening here is we are having to allocate this grouping just so that I can do a count, right? Which is kind of annoying to end up having to do because once again, it causes an extra allocation. We have to have this group iterator to be able to play with. Now, LINQ comes with new methods, so specifically count by. So now, rather than having to go through and group things and then count them after the fact and deal with that middle grouping being allocated for you, you can just straight count, and it comes back. Once again, online people, there's roaring applause. You're missing out. Same thing down here, aggregate by, with the same idea of being able to go through and do that aggregate call without necessarily needing to allocate a grouping enumerator in the middle. So simple extra overloads that just make life a little bit easier. I realize I probably made this example more complicated than it needed to be with extra fancy stuff of converting the enumerable out into an array and then inline array syntax and all of that. So I crammed a lot into as few characters as I possibly could. I'm sorry. Questions? Comments? OK, keep going then. OK. JSON serialization, something else that most of us are probably very familiar with. So in ye olden days, Newtonsoft.json was the king of the NuGet packages and is still very highly ranked on NuGet.org because it was the default for so many years, especially in ASP.NET Core. Newtonsoft is a wonderful library, and when Microsoft introduced System.Text.Json, arguably is kind of a competitor, the idea was Newtonsoft had more features, but System.Text.Json was more performant and ran faster. So you had your choice. Do you want to run fast or do you want to have features? And slowly, System.Text.Json has been getting more and more features added to it because Microsoft refuses to give up any positions on their benchmark tests and insists that System.Text.Json must always run fast. And because of that, there are a handful of features that they may never add that Newtonsoft has because it's impossible to do it and run fast. And they say, just don't do that. So you still have the choice. But one of the key things that Newtonsoft ran on was being able to pull back a JSON schema. Dan?
Stokes had a question back on the grouping.
Yeah.
Under the covers, does that do the same allocation as previously? And it's just syntactic sugar for us, or is that actually changing
Ah, yes. So
the
is
memory allocation of this LINQ statement?
yeah. So the question being is, does the aggregate by and count by do the same thing under the hood, or is it and just being fun syntactic sugar? No, it actually does avoid that middle allocation, which is great. Good question, Stokes. Okay, switching back. So one of the new things that is now here in System.Text.Json is the ability to actually pull back a JSON schema. So for people who are actually using JSON schemas to validate payloads or similar or generate from, System.Text.Json now fully supports it. So if we go here and terminal, gimme, right? So if we .NET run this guy, I know, shocking to everybody, we now get a JSON schema coming back that is now generated for us. So if your purpose for using Newtonsoft was for the JSON schema feature, that is now something that is available to you in System.Text.Json as well. But wait, there's more. I know, people have been waiting for that this whole time, going, where's the killer features? Oh, we're closing in on them. System.Text.Json also comes with a little bit more coolness and options for customization. Because before, this was one of the areas where we lacked some extra features. So if we go here, and I learn how to spell, Copilot, help me. Come on, do your job and actually do all of my work for me. All right? So down inside of here, we actually come with things like property name handling, number handling, so that it can actually figure out, hang on, when you tell me that age is going to be of type integer, should I actually put in the appropriate validation stuff? Could you have written that regex yourself? Probably. But now you don't have to. And it will go through and populate it as well. You'll also note that it switched to the kebab case upper. I probably should have picked something that actually had multiple words so that you could see the little hyphen in the middle. Trust me, it puts hyphens in the middle. I'm trying to remember the options. I think it's camel case upper, kebab case upper, and Pascal case and upper, I think, are the 6 options on that enum. But then you'll also note that we also get unmapped member handling. Because before, we didn't necessarily have a way of specifying, hey, what should you do if you get a JSON payload with extra stuff beyond what you expect, right? Should that be a failure, or should that be just ignore it, right? I only wrote as much C# as the stuff I care about. I know there's more stuff in the payload. We're going to move on. Yep. Okay. Let's keep going. See, we got more stuff in JSON. More stuff. OK, so beyond just schema validation stuff, we actually get more options to us around serialization and deserialization, the stuff that we actually do most of the time. So, for example, indentation, right indented. We also have this respect required constructor parameters. So before System.Text.Json implicitly treated constructor parameters as optional, which was kind of annoying. Because if you wanted it to deserialize into something that had a non-default constructor, you had to just kind of deal with the errors. Now we can actually say, OK, treat that as a required parameter. It also can respect nullable type annotations. So for people unfamiliar with this, this is the question mark that we often will put in front of things to take something that was non-nullable and declare it that it could possibly be null. So we call it nullable reference types. It is arguably something that the C# team would love to change the default of and go the opposite on, except for that's not how C# started, and that would be a breaking backwards compatibility change, and they really hate breaking back compat if they can ever help it. But we can now have it actually respect our nullable annotations to say, OK, if I say that this string is going to be non-nullable, darn it, you better give me a non-null value to be able to pass through here. And I believe the other one's up above. So if we take a look down here, right, so the missing age and valid values for last name are what we are looking at. So if we take a look at our person record, we've modified it slightly. So first name is now nullable. So we are perfectly happy to say, well, this thing can be optional, and I'm very fine letting a null through. Last name, we are saying, no, 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 this is absolutely required, and it must be non-null. And then down here, we can see that we've got this JSON converter for job, right? So we might have various jobs, and occasionally people like to send enum values through with as strings effectively rather than ints. We run into this on a couple of our clients where the API does this for whatever reason. And you don't want the string value to, we'll say, pollute up your nice C# enum. So we will say, rather than the IT manager, which is apparently the customer standard here, it really should be digital overlord. That is the appropriate value that I would like to see in all of my code. So if we take this guy here, and I stop closing my terminal, all right, so if we .NET run this guy, boom, and then you get points if you can remember how to spell .NET during a .NET talk, and we can see we threw an exception. This is actually good. So converting null literal or possible null value to non-nullable type down here, and then the System.Text.Json actual error, person was missing required properties, including the name age. So you'll note not only did they do the check, but they actually went to the effort of giving us a useful error message. Something that if I saw in a log, I might actually understand, oh, I should specify an age parameter because that wasn't there. All right, so if we come in here and say, OK, fine, we will be happy. We will give you an age 25. Great. Copilot, if you're going to help, actually help. Either that or get out of the way. All right, so we go through and we can run this guy. And now we get one more error. The property or field last name does not allow setting null values. Okay? Consider updating its nullability annotation. No, you don't make it non-null. You tell the thing sending you the JSON that you probably should actually send me a value. So John Doe sounds like a great name. And now if we run this guy, we can see here that this was our JSON string, and then it actually deserialized appropriately. And you can see here the difference between the enum value of job. So Wizard of Lightbulb moments from Bug Whisper to be able to pass things through. Because you'll note here, job, you'll note I sent the enum through as an int, right? Because enums are just named integers. That's still perfectly valid, right? We can go through and say, well, OK, let's actually switch it to one of the values. I just want to make sure that it's not going to mess with me when I do that. Right? So if we go through and specify the string value that we came through of Bug Whisper, we now actually get developer coming through. Right? So whoop, happiness. Questions, comments? That's fine. I'll just take the roaring applause. That'll work. Sorry, go ahead. Yes, roaring applause. We'll go with it. OK. So now on to something that we all were clearly missing. We all love our GUIDs because GUIDs are awesome. And so we get an update to our GUIDs. I know, people didn't realize we needed one, but we get one. Isn't that exciting? So, update, thank you. Close. All right, so we're just going to, well, we'll talk through it and then we'll run it. OK, so most people are familiar with GUIDs. You call GUID new GUID to generate a random GUID. Great. Everyone's excited. You do not call the constructor on GUID because you will get GUID.empty. That is not what you want. Most of the time you want GUID new GUID. But the specification for v7 of a GUID actually allows for ordering. So this is something that people would sometimes get with their database, where if you just randomly generate GUIDs, by definition, they're supposed to be cryptographically random. So there should be no deterministic way to sort these. Sometimes I've seen people do GUID new GUID as a way of doing a shuffle algorithm. Because it's like, if I just sort by this, it's going to be very, very random, and that's what I want. Great, right? But v7 leaves parts of the GUID available based upon a timestamp for ordering. That way they can come through in a deterministic order, and you can actually order these GUIDs. So if we run this guy, we'll take a look. Right? At some point, I'm going to just .NET run. All right, so if we look at the top, the first 5 GUIDs, I mean, from my eyes, those look really, really random. So great. But we get down to the next set of GUIDs, and we can start to see something about the beginning parts of these that are very much in order. Right? If we take a look, this guy here, whoop, right? That first bit and that first bit there, all the way up to, you know, about there and about there. These are coming through from a timestamp. So now, if you would like to still have the benefits of a GUID, but be able to then sort them, you can go through and do so. The new API is just new static methods that exist on the GUID class of create version 7. And then there is also an overload that allows you to pass a date-time offset. So if you want to be able to say, OK, I know something about when I'm generating these. I want to make sure that these are coming through on a day. Or I need to generate some GUIDs that are before this particular point in time. You now have a way of doing so.
Does that mean basically now you could use a GUID for a clustered index on a database because it's not going to do random inserts all over the place?
Yeah, so the question being, can you now use this for like a clustered index on a database since you can force them in? Yes, that is one of the prime use cases for this, is when you still need to have that GUID ID for uniqueness, but have something about the sorting. Because some databases offered you the ability to generate these sequential GUIDs to be able to go through and do it. Because quite often people are like, well, I want the GUID as my PK, but I also need to sort. And so rather than having to do some sort of clustered index or whatever, right, now you can just gen one of these things up. And so now it is built right into the SDK rather than having to rely on something outside of it. Great question. OK. We'll get to something slightly more complicated. Threading. OK, so inside of .NET, we have the task parallel library, which allows us to go through and do threading in a more sane way. Most people will know this feature as async and await. A task just represents some unit of work that will be done on a background thread. And then when it is done, it comes back to the original caller and can continue on. It's functionally how the async and await works. On the task class, we now have this new WhenEach method. Now, we previously already had things like WhenAll, where you could feed it a collection of tasks and say, I would like you to wait until all of these tasks are done. And then we are going to go through and iterate over the top of them. Now, we can actually end up doing a WhenEach. Because this was something that people would oftentimes end up abusing like parallel for each to do. It's, I want to start a set of tasks. And when each of them finish, I want to do some extra continuation on it. Right? You can build up the tasks and kind of chain them together with either functions or similar to make this work. But now we can just do this directly. So if we kick this guy off, .NET run, you can see 1, 9, 3, 7, 5. Huzzah! See? So we generate a random amount that we are going to delay for each of these, and then we just output the original value. So effectively, which of these values from 1 to 10 ended up being there. The important thing here that Task.WhenEach returns an async enumerable. So this is something that ends up using the async for each to be able to iterate across. So the await in front of the for each is very, very intentional for what this is going to end up actually returning back to you. The other key thing to note is that the actual thing coming out of that iterator from Task.WhenEach is the task itself. So this is something that's actually going to hand you back the task where you end up doing task to result. Now in general, calling .result on a task is usually considered a very bad idea, because task.result is one of the ways inside of the TPL that you can deadlock yourself. Things like .result, getResult, there's one more on there that I can't remember the name of, that if you are just manually invoking that on a task, it can cause your thread to block, and if the task running needs your thread to complete, you now deadlock. So it's generally a bad idea. However, task.result is safe to call if you know that the task is already in a completed state. Because the only time you deadlock is when the task needs your thread to finish running. But if it's already completed, it doesn't need any other threads to finish running. It's already done. It's now just sitting there holding on to a value for you to say, here, go ahead and do something with it. Right? So in this case, you can actually go through and pull it back. You can actually go through and check if it actually did run to completion, if there was an exception, or because in this case, it's obviously not going to throw any exceptions, but it is possible when you're iterating over this, some of these tasks may fail. Right? This may be going out and making a web service call where some of them come back in a failed state, and so you might want to actually check more than just, stop opening, stupid pop-up. Rather than just accessing the result, you might want to look at task.exception or similar. Okay? Now, I did kind of tell a small lie. So if we look here, right, var foo, the return type from here is actually somewhat difficult to, we may have to drop into Visual Studio for this, is actually somewhat difficult to declare. So normally you'd think this was some sort of async enumerable. Let's see, will you just let me open? No, okay, fine. Back over to my beloved Kraken, and I will pop my File Explorer, and then we'll just open the CS Proj directly, because Visual Studio will do this nicer for me than VS Code. Right, so come here, come here. All right, so if we look at what this var ends up being, oh, I lied. It is going to be an async enumerable. Dang it. Okay, I apologize. I was running on this on a preview build, and it showed me a value 1 earlier. So I'm going to ignore that for the moment. Hand wave, there was nothing to see here.
So you lied to us about lying to us?
Yes, I lied to you about lying to you. That is a great way of phrasing it. Thank you. OK, and with that, that is all of the cool stuff, or at least what I deem to be the cool stuff in .NET 9, C# 13. There is more stuff that is out there under those links if people actually go to it. Again, the branch, if it will let me switch, is the tooling stuff branch down here. This main intro slide has a whole bunch of stuff. A lot of what is out there that I didn't bother to cover ends up being like unsafe code, pointers, implicit method groups, things that most people are probably not going to use in day-to-day coding. This is if you are writing something high performance, trying to deal with allocations, doing something that needs to interop, there is some cool stuff there. But I can count on one hand the number of projects I've actually needed those features on. So it is somewhat rare and a little more esoteric. So with that, any questions? Dan is looking at me like he's about to kick me off and throw something heavy. I can't tell.
Not gonna go into yet.
Cool.
I have one question. Is
Ben.
there any custom collection types you can use for the params modifier? So right now it's only for recognized collection types, but can you create a custom collection type
Oh, I see.
Basically, is the implementation on the inside of that, of like iNickle live collection, something you can manipulate?
So the question being is, for the params collection stuff, could you end up having it be a custom collection type? That is a wonderful question. I do not know. I might have to go look at the spec that they put out for it. The nice part is this is open source. Their language design meetings are done on YouTube. Anyone can go and watch and participate and join in. And the spec is there. I would probably have to go and look. It would not shock me. Duck typing, that kind of stuff, is the type of thing they really enjoy doing. But I would probably have to check and see. Dan.
Stokes had a question about, do you see yourself using the virtual property a lot now?
The virtual property a lot now. Oh, the partial property? Is that the, I assume that's what Stokes is referring to?
Potentially?
I'm going to go with, so the partial stuff, I don't know that,
Yes,
perfect. I don't know that many people are going to be using the partial feature directly. Where I see it likely coming into play is with source generators. So where people are probably going to be using it is where a source generator is going to generate you a partial property, and you, if you would like to use it, have to provide an implementation in your code. So that I think is going to be the likely indicator of where people will run across it, is a library you reference is going to gen you a partial property, and then you need to know something about the feature in order to properly implement it. Again, the key thing there being remembering that when you go to implement a partial property, your get sets can't just be get semicolon, set semicolon. You actually have to provide some implementation, whether that be a backing field, expression off to something else. Right? The compiler has to know the difference between the implementing side of the partial and the declaring side of the partial. Good question, Stokes. So yeah, I don't know if I necessarily will use it, but I do write source generators, so I'm probably that. But I think the number of authors of source generators is drastically inferior to the consumers of source generators. And for most of you, you've probably actually run into them. Microsoft has built-in ones for things like regex, logger, similar. Those are worth looking into if you aren't already using them. Technically, the iLogger source generator did get an update in this as well. It just allows you to pass a parameter into a class. So it wasn't a use case that I've ever used, and I questioned when it was going to be used, so I didn't bother to include it. But if you are using the source generator for iLogger and you would like to be able to pass an iLogger in as a constructor parameter, congratulations. .NET 9 is for you. Great. If there's no more questions, we'll go ahead and wrap up. Thank you, everyone, for coming. And we will see everybody next month. Like Dan said, it is Season of AI, where the amazing Dan will be presenting on something AI. I do not remember the exact topic.
Thank you, Kevin.
Thank you.
All right, now some hard questions.